GATE Academy YouTube channel. Today we are having a very important live quiz webinar for the subject thermodynamics, and that will be of 30 minutes. You can join along with your friends. I'll tell you how to join and attend this live quiz webinar for the subject thermodynamics. That will be of 30 minutes. And today we are going to take a very important topic which will help you to prepare for the GATE examination. That is your thermodynamic relations. In there, we are going to see the Maxwell equations, TDS equations, and other important equations. Let's start. So, first of all, there's an instruction for playing the quiz, how we can play the quiz here. So, you can play the quiz in laptop or with mobile. So if you are opening the page using the given link here, you can see bit.ly/tga080E. So you can open this page in laptop. So you can use the two tab in the laptop. In one page, you can see the YouTube channel, and in the other page, you can open this link to play the quiz. Or if you're having only one device like Android mobile, so you can use the split screen feature in the Android mobile and you can play the quiz, and you can use this link for playing the quiz, right? And I hope all of you are getting the YouTube channel link also. And in the YouTube channel also, you will be able to find the link so that you can join the quiz bit.ly/tga080E, right? So you can definitely inform your friends to join this live webinar for the subject thermodynamics. And I'll tell you how we can proceed further, what are the instructions, and how we can play the quiz. Yes, the first question here itself says how to play the quiz. That I had already informed you about how to join the quiz in the laptop and mobile. You can, in the laptop, if you're using, you can open the two tab. One tab for watching the YouTube channel, and the other using the link you can open and you can play the quiz. So there will be no negative points here. We'll be having some 4 to 5 questions, and the detail of the question, like whether it is MCQ, MSQ or numerical answer type, that will be mentioned. And you can attempt all the questions because there is no negative points. Number of points and type of question will be displayed. Correct? That already I mentioned that. What will be the total number of points? Suppose some question is very easy, so we'll be having less number of points. If the question is tough, then if you're solving that question and getting the correct answer, and if you're marking the correct answer, you'll be getting the more number of points. So tougher the question, the points will be more. Yes, tougher the question, more will be the points. So, and the most important is you have to also give the correct answer in the given frame of time. And if you're able to give the answer earliest, correct, then more points will be awarded to you. So faster you answer, higher will be the score for you. Okay. So after that, we'll be joining the quiz. Students will log in into this quiz page. So please use this link bit.ly/tga080E for joining the quiz. You can also inform to your friends. You can join along with your friends. More number of students will be there, then you will feel more interest to play the quiz. Okay. So now, yeah, at this time you can join the quiz actually. So using the link given on the top of the page, you can also find the link on the YouTube channel chat box. Please join the webinar to play the live quiz for the subject thermodynamics, and today's topic is thermodynamic relations. Asisa, most welcome. Good evening. I hope you are not facing any problem in joining the quiz, right? So if you are facing any problem, you can place your doubts on the chat box in the YouTube channel. I am just watching your messages also. I can reply to you. या डिस्क्रिप्शन में क्या लिंक है सर? श्रेयस फर्स्ट, आई होप यू आर एबल टू ज्वाइन. Yeah, Shreyas Gandhi, if you're facing any problem, you can mention me in the chat box YouTube channel. And I will also suggest you to write down your full name, right? Don't write Sky, SSG, all these things, right? It will be better if you can put your full name. That is already suggested in the first class as well as in all the places to mention your correct name, at least only one word, right? If you're facing any difficulty to join this live quiz, please tell me. So bit.ly/tgs080E, you can use this link to open this page and you can join the live quiz. Shreyas Gandhi, so everything is fine, right? No problem. Audio, video, everything is clear? Yes, okay. Thank you. We'll just wait for 1 minute so that others can join. You can also inform your friends to join. Today's topic is very important, thermodynamic relations we are going to see. And I'll tell you very important thing, that how we can write the formula for the Maxwell equations, complete equations, right? Without remembering the formula, right? So this is a very complicated formula because sign conventions are there, plus, minus, reciprocal. So it is difficult to write and remember the formula. But today I'll give you an important trick. By that trick, you can always remember anywhere, any place, you can write that particular Maxwell equations. And if you are attempting any question related to Maxwell equation, then you will be able to write down the correct answer, no doubt. Okay. Yes, Rudra, welcome back. Good evening. Okay, so now we are going to start the quiz actually. Okay. So if some of your friends are interested, please tell them to join the quiz actually by sending the link, or you can also share the link in your WhatsApp or any other group that is if mechanical students are there. Okay, fine. Let's start the quiz now. Okay. So you will be getting the questions one after the another, right? One after the another. There will be 4 to 5 questions, and you'll be given time like 90 seconds or 120 seconds, depending upon the type of question. And please take your full time, and then you, after deciding the final answer, whether it's numerical or objective question, you can mark your answers, right? And if you're having any doubt on the how to play the quiz or any difficulty, you can tell me in the chat box in the YouTube channel. Okay, let's start. So this is a question 1 of 4, first question out of 4 questions. A gas having a negative Joule-Thomson coefficient. This is also known as Joule-Kelvin coefficient. Mu is less than 0. Okay, mu is known as Joule-Thomson coefficient. When throttled, will. So when this gas is throttled, what will happen? It will become cooler, become warmer, remain at the same temperature, either be cooled or warmer depending upon the type of gas. So very easy question for 60 seconds. Only one option is correct. Think properly and mark the correct answer. After that, you will be awarded points for that correct answer. So time over now. Yes, so yes, one person has given the right answer, become warmer. That's correct. So I'll tell you why it will become warmer. I'm having a complete graph for the Joule-Kelvin coefficient. I'll tell you why it is warmer, what is inversion point, all things related to the Joule-Thomson coefficient. Okay, let's go to the leaderboard. So Rudra, very good. You have given the correct answer and you got the 60 points for this correct answer, right? And Shreyas Gandhi, definitely you can also try for the next question. And please think properly and then you can answer. Okay, let's go to the next question. Question 2 of 4. This question rewards more points. This is a direct question from the Maxwell equation, one of the most important topic in the subject thermodynamics for GATE examination. So Maxwell and TDS are two important equations, and this is one question out of Maxwell equation. Take care of the positive and negative sign also. And there's a trick. Without knowing anything, you can directly give the answer. And this type of question definitely you can save time in the examination. One person is given the right answer. Very good. I think Rudra or Shreyas Gandhi. Okay. So you will be getting full points for this correct answer, definitely. Let's go to the leaderboard. Oh, wow. Shreyas Gandhi. So you can see in the second question, you have got the higher points, 68 points. Very nice. Okay, so Rudra, why you have not marked the answer actually? Can you tell me the reason? Okay, let's go to the next question. Second last question. This is a numerical, right? So numerical answer type question. For water at 25 degrees centigrade, dps by dts, that is saturation pressure and temperature is given. Ratio 0.189 kilopascal per Kelvin. PS is the saturation pressure in kilopascal and TS is the saturation temperature in Kelvin. And the specific volume of dry saturated vapor is 43.38 meter cube per kg. Assume that the specific volume of liquid is negligible in comparison with that of vapor, so that we can put 0 here. Using the Clausius-Clapeyron equation, an estimate of the enthalpy of evaporation, that is HFG of water at 25 degrees centigrade, same temperature, there we have mentioned the PS and TS value in kilojoule per kg is. Okay, so please try. Requesting all of you to mark the correct answer. Please try your best. If you're facing any difficulty, you can tell me. So you must be knowing about the Clausius-Clapeyron equation, right? Direct formula based question on the topic of Clausius-Clapeyron equation. Okay, so the correct answer is 2443. So I think none of you got the right answer. No problem. I'll give you the correct solution and explanation for this question. And maybe there may be some calculation mistake or any kind of minor mistake. Okay, let's go to the next question and please try. And before that, there will be leaderboard. Points will remain same. Okay, next. Last question. This is a very easy question. You can see here. Which one of the following relation is wrong? Okay. So multiple choice question, one question is there which is wrong actually, right? One option is wrong actually. So which one is wrong option? If you know the Maxwell equations, definitely you can find it out. You have to check the minor details also, not only the parameters, but also the sign, reciprocal, whether it is directly proportional or inversely proportional like this. After this, I'll give you the complete explanation and solution for all the 4 questions. Okay. So very good. I got at least one correct answer. Very nice. And let's go. Who had given the correct answer? Yes, Gandhi. Very good. I think you got good number of points, 127. Okay. So you are the winner definitely. So let's go to the next session, that is our solution part, explanation part. Okay. So I'm changing the page here. Just a second now. Yeah. I hope the new page is visible to you. Yes, correct. Fine. So let's go to the first question here. As we have seen, a gas having a negative Joule-Thomson coefficient, correct? Negative Joule-Thomson coefficient, that is your mu is less than 0. When throttle will become cooler, warmer, remain at same temperature, either be cooler or warmer depending upon the type of gas. So answer is B. We have seen and it is written also. So no problem to mark the right answer. Become warmer. But why it is warmer, that we are going to see, right? So Joule-Thomson coefficient, right? So that is written as mu J, right? Mu J, or simply you can write mu also. This coefficient is equal to change in temperature by change in pressure, and all this process has taken place as constant enthalpy. H is constant, right? So this is the equation valid for the Joule-Thomson coefficient, dou T by dou P, and at enthalpy constant, right? Now what is given here, just try to understand. Mu J is negative, right? Mu J is negative. How we can know that what will happen to the temperature? Mu J is negative, it is less than 0, is negative. Now Joule-Thomson coefficient, so this is a throttling process, right? You can see very important point to note. Throttled. Throttling is an irreversible expansion process. What is throttling? Throttling is an irreversible expansion process. Okay, irreversible expansion process. So when you talk about the expansion means pressure must decrease. Pressure must decrease. Now you can see out of this, pressure is decreasing, pressure is negative, right? Pressure is negative. So what should be the value of temperature? Temperature should be positive or negative, so that we can get on the left hand side, we are having negative sign. To get this negative sign, this should be, temperature should be plus, right? Then plus minus, we are getting minus, correct? That means temperature is increasing. If temperature is increasing, then it will become warmer or become hot. Okay, got it? Any doubt you can ask me. So this is the idea we are following for the writing the value of mu J. Now next question, for simple compressible system, we are having the specific volume, entropy, pressure, and temperature mentioned like this. As per Maxwell equation, you can see what is mentioned here. Dou V by dou S at constant pressure is equal to what? Correct? Is equal to what? So we have four options. A, B option you can see here, and C, D option is here. And the answer is D. Answer is D. So I just want to write down the first two equations so that you will come to know that how we can write. So Maxwell equation, first two equation I'll write down here. Like for this is first equation I'll write down. Dou T, dou V S equal to this side. How we can write here, you can see. So first relation is TVS. So TVS simply you can write here. So now interchange this, put S inside, V outside. And this Maxwell equation is a relation between only four parameters like pressure, temperature, volume, entropy. So what is missing here? Pressure. So you can see TVS, right? So S, now for this side, you have to interchange the position and you have to write V. If TV is coming, that will be minus. Second equation I'm writing here, TPS. Okay. Similarly, I'll write down this side, complete equation. Put S inside and P outside, interchange the position. And what is missing here? TPS, you can T is here, P is here, S here. V is missing, right? V is missing. So I'll write V. So now you can see here, very important to note that sometimes they will give you the LHS, sometimes RHS. So don't confuse. So that means you have to write down this all four equations, then only you can compare. That is a good idea actually. Okay. So now you can see in the given question, this part is given, right? Dou V by dou S, you can see here. Dou V by dou S, P is given. So this is equal to what? This is equal to this part I will write here. Dou T by dou P at constant entropy S. That is the correct answer. You can see dou T by dou P S. Okay, understood? Now let's go to the numerical part here. This is Clausius-Clapeyron equation. So no doubt, first of all, I write down the given data and then I'll try to solve this question. So given is your temperature T is equal to 25 degree centigrade. Okay, at this temperature, we are having the pressure by temperature, saturation, all are saturation values. dPs by dTs is 0.189 kilopascal per Kelvin. Unit is also correct. You can see here Vg and the specific volume of dry saturated vapor. What is dry saturated vapor? Correct. Dry saturated means the Dynamics fraction is x equal to 1 and there the value will be G. Vg is equal to 43.38 meter cube per kg. Okay. Assume that the specific volume liquid is negligible. That means Vf is 0. Question is, using the Clausius-Clapeyron equation, estimate the enthalpy of evaporation. That is, we have to find HFG, right? We have to find HFG in kilojoule per kg. This unit is given, right? Answer is also given. So how we can write down this? So look into the solution. So we have the Clausius-Clapeyron equation as dPs by dTs equal to HFG by Ts, saturation temperature, into Vg minus of Vf. This is a direct formula and this is only known as Clausius-Clapeyron equation, this equation. Okay, Clausius-Clapeyron equation. So HFG, only you have to substitute the value, that's nothing you have to do. This value is given 0.189. HFG, only you have to take care of the unit if there is a change. HFG, Ts, saturation temperature is given 25 years. You know, in thermodynamics and anywhere, you are not using this temperature in degree centigrade. You have to convert into Kelvin. So how much it will be? 273 plus 275, that is 298 Kelvin. Vg minus Vf. Vg is your 43.38 minus Vf. Vf is 0. That's all. You can use your calculator and tell me the correct answer, how much you are getting the value of HFG. You will be getting HFG is equal to 2443.2. Correct. So this is the correct answer, kilojoule per kg. Correct. Understood, everyone? Yeah. Any doubt you can ask me. I can see your chat box. Okay. Let's go to the next question. That is the last question. This is also your, which one of the following relation is wrong, right? Which of the following relation? Now, very good thing I'll do here. I'll write down the equation, complete Maxwell equation, all 4 equation. You can see, I'll write down the all 4 equation. First one, you can see how I'm writing here. I told you, TVS. Just you have to remember this, TVS and TPS. So this will partial differentiation will mean say put S inside and V outside, correct? Pressure is remaining, so pressure will come here and minus sign will come by TVS. Only if T and V is coming, then minus sign will come. Then TPS. Okay, similar, I'll do it here. Partial differentiation remains same. Put S inside, P outside. TPS is there. Okay, and so TP is here, entropy is there. What is missing? Volume, right? Pressure, temperature, volume, entropy. Pressure, temperature, volume, entropy, all 4. Now, third one, what we have to do? Just make the reciprocal of this particular ratio. Dou T by dou P, no. So I will write dou P by dou T. Third and fourth is a relation between only pressure, temperature, and volume on the left hand side. So just interchange this. Dou P by dou T, you write it down. So pressure, temperature, volume is missing here. Right hand side, same logic. Put V inside, T outside. What is missing here? Pressure, temperature, volume is there, entropy. TV is there, no. So no minus sign. Fourth one. Then now you have made the reciprocal for this. For fourth one, you have made the reciprocal for this. So volume by temperature. Okay. And definitely S will come. Pressure will come because pressure, temperature, volume. Now put P inside, T outside. What is missing? Entropy is missing. TV is there, yes. TV is there, so minus sign. That's all complete. Okay. So without knowing anything, just to save your time, even if you know that how to derive this equation, that's good enough. But in the examination, it's always very important to do the smart work. Just write down this equation somewhere and then compare. Now you can tell me which is the correct answer. Okay, let us check now. TVS is correct. First equation, it is looking like dou T by dou SV. Correct. TVS is wrong only. You can see S is because this is the problem here, right? So A is wrong. What about B? You can see TPS, correct only this side. VSP, correct only. C part, pressure, temperature, volume, correct. Dou S by dou VT, yes, correct. Dou S by, now you can see, they can put this side and change into LHS, RHS, no problem. Minus sign also here and there, just see. Dou V by dou TP, correct here. Minus sign, you can put that side, no problem. And dou S by dou PT, exactly correct. So this is the wrong answer. Okay, so wrong option, correct answer is understood. Please reply. Shreyas Gandhi, Rudra. Very important trick I given you today, how to write down the Maxwell equation. If you can hear me, you can respond to me. Okay, so thank you. We'll meet next time for the other session for the subject thermodynamics live quiz webinar. Thank you all.